simulation is possible. We are interested now in the simulation of our project. And the simulation is done using this file that is not used in the top level and is not being synthesizable. This file is the test bench, and we have to tell the system in settings where is the test bench. So if we go to simulation, you have to select the simulator, Quest Intel FPGA, our design description language, that is HDL for us, but it can be also Verilog HDL or System Verilog. The time scale is not important. We can select the output directory. So in our project, we can create a directory that is called sims. Okay, sims. Or you can have just a simulation directory for all your project. It is dependent on what you want to do. And next, here we have to tell the system what is the file, the test bench to compile. So the test bench name is tb_top. And we have to select here, we can specify then simulation time, for our case is 4000 nanoseconds, and we can select our text bench from the file. So this here, test bench top. Add to the list, select, and set OK. Select this one and say OK. And we have selected the test bench. And this is the file. Just select. We can say apply. OK. And now we are ready to run the simulation tool. So we can run the simulation to test before programming the FPGA if our project is correct. Questa has been launched. We have to organize better the input and the output. For instance, this is the global output of the BCD to 7 segment display, the Q bus, Q720. This is the decimal point input, and this is the in BCD input. These are the input of the full adder. What is missing here are the output of the full adder that we can read from in BCD input, but it is better to show also them. So we can go here, and we see here when we select that under the object that we have cout and some bit. So we can add them to the waveform viewer. So the bit sum can be shown here, and the bit cout can be shown here. So to display input-output of our devices under test in the test bench, it is sufficient to select the device under test, and under object you can have all inputs and outputs to be shown. And inside the device you can also have the internal signals if you want to display also internal signals, but usually it is not required, it is not necessary. So now we have our simulation. The simulation ends at 4000 nanoseconds. We go to the beginning. We can have a zoom out, O, capital letters. So we show groups of 200 nanoseconds. Okay. So initially we have A, B, C all at 0. The output sum and cout are 0. The input of the BCD to 7 segment display is 0. And to display 0 in the 7 segment display, the output of the BCD to 7 segment display is C0. That is 1, 1, 0, 0, 0, 0, 0, 0. That is exactly what we have here decoded here in the BCD to 7 segment display. So if we want to display 0, the output is 1100, that is the letter C, hexadecimal, and 000, that is equivalent to 0. So here in output, we should find these values. This, for instance, is F9. This is A4, that corresponds to the value we want to display. So 0, and for instance, if we want to display 1, because 1 bit here, the bit A becomes 1 after 200 nanoseconds, we have to display F9. That is exactly this value, F9, when we want to display 1. Next 200 nanoseconds, there is input B at 1, so the output is always 1, and we display always F9, that is 1. But when 2 bit after other 200 nanoseconds comes 1, for instance, A is 1, B is 1, the output is chout 1, sum 0. So the input to the BCD27 segment display is 2, and to display 2, we need the output A4. That is, to display 2, we need A4, that is this one. Next, we have still just 1 bit at 1, so the output of the full adder is 1, the input of the BCD27 segment display is 1, and to display 1, we have the output F9. Next, we have 2 bit 1, so the output of the full adder is 2, the input of the 7 segment display is 2, and we display 2, A4. Next, we have always 2 bit at 1, so we display 2. Finally, here we have 3 bits, all the bits, the inputs of the full adder at 1. So the output of the full adder is 1, 1, that is 3. So the input of the BCD27 segment display driver is 3, and we display B0 that corresponds to 3. 1, 0, 1, 1 is B0. Next, the things changes because the output of the full adder is 0, but we turn on the with the switch, the fourth switch of the board, we turn on the input in BCD2 that is equal to 4. So we have to display 4 on the display. And when we want to display 4, we have 9, 9. But why here we have 1, 9? Because we want to display 4, but also the decimal point should be activated, because also we have activated the InBCD2 bit, but also the decimal point bit. And when we activate the decimal point bit, the most significant bit of the output should be 0 if we want to turn on. So we want display 4 that corresponds to 9, 9, but since also this bit is 1, also the 7th bit turns to 0, and so we display 1, 9, because also the decimal point should be turned on. To display 5, that is 1 bit of the full adder, the full adder provides 1, but we also have at 1 this bit of the input of the BCD27 segment display, so the 7 segment display has an input 5. And 5 corresponds to 9, 2. And so we have 9, 2, but not 9, 1, 2, because the 7th bit, this the most significant bit, is turned to 0 here, because we want to turn on the decimal point. And so it is 1, 2, so it is correct. And so on, you can test 5. Here the result is always 5, 6, 5 again, 6. Here we have 7. And at the end, we have to display 8. That corresponds to 8 because we turned off this bit and turned on this bit. The decimal point turns off, so we the input of the full adder are 0, and to display 8 we have this configuration that is 8, 0. That is exactly what we obtain here. When we add 1, we want to display 9. To display 9, we have 9, 8. Hexadecimal 98, just here. So we have verified uh, all possible changes of the input, and we have verified that the system works as expected. Next, we can save the waveform, save format. We can browse on the folder project to teach, and we can see here we have saved this one. We can also save such simulation. So wave.do. So when we run next simulation, we can load this file with already the time scale already set. So this is a complete project flux for this example.